Today we're looking at lesson 5.1, and lesson 5.1 is on inverses. Specifically today we're going to be looking at, given a graph or a table of a function, being able to represent the inverse as a graph or a table. So what I want you to do is I want you to pause the video and take a second and look at these two tables. The table on the left is your original function, f of x, and the table on the right is the inverse of f of x. And we can see how that is denoted up here. That represents our inverse of our original function f of x. So take a look at these two tables, and what do you notice about the values in the table? Now what you should notice is that in f of x, we have our x values, our inputs of 3, 4, and -3. If we look at our inverse, those are actually our y values, our outputs, 3, 4, -3. So if we were to compare these two, if we look at our inputs, our x values of f of x, and our y values of our inverse, they're the same. Also, if we were to look at our outputs of f of x, we have 7, 9, and -5. However, on our inverse, those are our x values, 7, 9, and -5. So if we look at f of x, our x values turn into our y values of our inverse, and our y values turn into our x values of our inverse. So what's happening is our x and y values are switching when we go from our original function to our inverse. So looking at the tables, we can discover that our inverse and our function are just switching our x and y values. So the definition of an inverse is when all the inputs and outputs are switched, we would say that the two equations are inverses of each other. So that means we're just switching our x and y values. So essentially we're switching our domain and range as well, because remember, domain is our x values and range is our y values. So if we were to think about it, if we had f of x, if we had a coordinate, it would be x, y. So if we had our inverse, our coordinate would be y, x. All we're doing is taking our original coordinate and switching it, and that becomes our inverse. We're switching x and y values. So if we're looking at a table here, an example when it says, given the following tables, fill in the missing values. So on the left side, we have our original function f of x. We have our inputs, which are x, and our outputs, which are y, on both of our tables. Inputs also is our domain, and outputs is our range. So if we have f of x, we know that we have our x values and our y values, and in our inverse, they're just going to be switched. So if we have an x value of -2, that means that becomes a y value on our inverse. So if we have -2 for our input of f of x, it becomes our output on our inverse. So if we have an x value in our inverse, it becomes the y value of our original function. So if we had 2, -4, it becomes -4, -2. So if we look at our next point here, if we have 2, -2, we have our x and y. If we flip those, it becomes our inverse. So we would have -2, 2. Then if we had a y value of 0, that would become our x value. And if we had a y value in our original function, that would be our x value. So we can see that we're flipping our x and y's when we have a representation of a function in a table. So we looked at a table, so now we're going to look at a graphic representation of inverses. So it says sketch the graph of the inverse of the function below. f of x equals square root of 2x minus 3 is graphed for you. So that means this line right here that we have graphed is f of x. So f of x gives us 3 coordinates. We have 1.50, 2, 1, and 6, 3. So if we wanted to graph our inverse, we would just take our xy coordinates and flip them to yx. So if we have xy on our inverse, we would have yx. So we would have 0, 1.5. If we had 2, 1, we'd have 1, 2. And if we had 6, 3, we'd have 3, 6. So I want to plot those points. So I'm at 0, 1.5. I'm at 1, 2. And I'm at 3, 6. So I have the same general shape. And that would be our inverse. So we can see that this is reflected over a line. So before we had, if we had a negative out in front, we were reflecting over the x-axis. If we had a negative inside, we were reflecting over the y-axis. When we have inverses, we're switching x and y, so we are reflecting over the line y equals x. So y equals x is just starting at 0 with a slope of 1. So we're going to be reflecting over this line. Y equals x is going to be our line of reflection. Every time we're taking an original function and we're finding its inverse, we are reflecting each of these points over this axis of y equals x. Something else is that we are not only switching our x and y's, but we're switching our domain and range. So from before, if we're looking at our original function, f of x, and we want to find our domain and our range, remember domain is our x values, range is our y values. Our domain, if we're looking at our x values, we start at 1.5. So we see that x has to be greater than 1.5. And our range, we start at 0 and we go up. So y has to be greater than 0. So if we look at our inverse, our domain and range should just be switched because we're just switching x and y's. So if we take a look at our graph, that should make sense. So our domain is our x values, and we start at 0 and we continue on. So our domain is x has to be greater than 0, and our range, we start at 1.5 on our y-axis, so y has to be greater than 1.5. So we can see that our domain and range have just switched. And one last example of graphing, we have f of x equals x minus 3 squared plus 2. So we can see that that's graphed here for us. We have f of x. It says identify 3 integral points, so that's just 3 points that are integers, and use them to sketch the graph of the inverse function that we have graphed for us. And include the line of reflection. So if I look at my original, I have a nice point right here, and that point is at 3, 2. I have 2 points here I could choose. I have a point here and here. I just need to pick 3 total points. It doesn't matter which ones I choose. So if I picked the next 2 nice points, I would be at 2, 3, and I would be at 4, 3. So if I were to take each one of these points and switch my x and y, that would be my inverse. So if I start with 2, 3, if I switch that, I would need to graph the point 3, 2. If I had 3, 2, I would need to graph 2, 3. And if I had the point 4, 3, I would need to switch them and graph point 3, 4. I'm going to have that same general shape, except this is going to be my inverse. Because my line of reflection of y equals x shows that each of these points is reflected over the line y equals x. And reflected over the line y equals x is my inverse. And remember, my domain and range would also switch.